have we done like indicate the molecule like polar, non-polar, or state, molecular shape?
Nope, not yet. Just
We
let
don't have to do that.
no. Oh, I think um, I probably at one point was photocopying it weird because I think I noticed like it does the same. It's basically the same thing over again. I don't know why this doesn't.
Yeah.
Yeah,
Maybe it's
it's
like a different system.
well, yeah. Just do the first 10 of them. I don't know why it did
Just
that.
do A and B.
No, well, you're gonna. What I mean by um, like, because I'm just gonna pull up the actual file that I put there. Um, apparently, I didn't realize that it was 4 pages. Um, and
It's 4 pages. I only printed off two.
yeah, it's only you only
Yeah,
need the
there's two up there by accident.
yeah, it's that's what it is. It was just a mistake, and I don't know why
Mr.
Adobe.
McKay,
Yes.
do you want us to, so you want us to print off those things, do them, and then do you want us to send pictures in?
Yeah, pictures, but you don't even have to print it. You could do it on loose leaf. Like you could just write number
Oh,
one
That's what
CF4.
that's what I was gonna do.
Yeah, just do it on loose leaf. Don't waste any paper. But
okay.
like
Thank you.
there shouldn't be a lot of I carbon tetrafluoride. Oh, well that's there may be like yeah, just do the first 2 pages. As long as you do like 1 and 2 or 3 and 4. That was probably from last year. Um, me being silly, but so what
Does it
I
have to say that if it's polar or non-polar?
I you can try once today. We're gonna go over just drawings. Like I'm just gonna do a quick. Let's go over those questions that I talked about yesterday, and then tomorrow we'll talk about shape and polarity. What? Oh no. Apparently I hit Control N at some point, and I have my Chapter 8 notes have nothing in them, and I saved over them. Oh, this is going to be fun. I have another copy somewhere, but oh, right, wow. So now I have to go. Just bear with me for a sec, because I'm an idiot.
So we have to do all 10 questions for this salmon, right?
Yeah.
And then we don't have to state the polar,
What
non-polar, molecular shape.
you will, but it will be like we haven't done it yet, so it's kind of we can't really do that yet.
Is the molecular shape the same as structural? Like, I thought it was the structural type.
It is and it isn't. Well, I that's something I'll talk about tomorrow. Right now, you can do the formula part. We'll deal with the rest. Just because I don't like, we got an email saying, "Oh, you're not supposed to be doing too much and only essential things." So today, I just want to do some examples. Like math this morning was only like half an hour, and then that's like all I want to do today is go through. Well, I'm gonna open this because I totally messed something up. I'm sorry. I'm wasting people's time. Or printer paper or whatever paper you have. And as long as it's somebody's leaving, like literally going out the door.
I just went into Alex's room.
Oh dear. So like this is gonna look slightly different because oh, there's what we're gonna do. So buzz off. The computer and the internet have been sketchy.
I can't see any of the numbers, man,
What?
on the assignment.
Okay, just what do you mean the numbers?
Like, so say if it was like H2O, I can't select the two. Like I don't know what the numbers are like at the end of it. If it's H and there's obviously gonna be.
Well, like if you're looking at the window like this, can you guys, let's see. If you click on those dots, you can download it and then just save the file. And then you should be able, like it's just a regular PDF, so it should be a little easier. So yesterday we talked about Lewis structures. Count the valence electrons. The least electronegative goes in the middle. We want some symmetry. Um, we did a couple of examples, and this is last year, so apparently I did saw it a little bit different. So we put dots around them, and apparently I'm a moron and totally messed something up today. So we're gonna do some of these. I may only do one of those two. We did C2H6 yesterday. Um, so starting, is that knocking for me? So OF2, we have one oxygen, which gives us 6 electrons. Oh, I think I just put Kate down for a nap, and I think she's talking. 2 fluorines, each one has 7. Either that or Ben's getting in trouble. No, Kate's talking. So we have 20 valence electrons in total. So that's our first thing is a counting thing. Which one of those two is going to go in the middle? Well, fluorine is the most electronegative, so it's probably going to be oxygen. So we're going to start with something like that. How many electrons need to go in between the oxygen and the fluorine? 2. We're going to always start with 2 in there. So some people like to do -4, 16. So now we've got to, and if you were in math this morning, when I change colors on the airliner, it does that stupid bing. I tried to find it out, but if I mute my volume, I can't hear you and you can't hear me, so it's just a giant pain in the butt. So we're going to have to deal with it. So fluorine has 2 here, so I need 1, 2, 3, 4, 5, 6. So that one has 8 now. 1, 2, 3, 4, 5, 6. That one has 8. So 2, 4, 6, 8, 10, 12. So that was 16 minus 12 is 4. Oxygen has 2 here and 2 here, so it needs 2 more here. And now we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oh, Kate is not happy.
I'll be right back. I'm gonna go for a second.
Okay. So personally, I like to put all my valence electrons in. I may have to run. I'm not gonna log off. I just need to go grab the monitor to check to see what she's doing. So I'll be back in a moment. Just one more sec. I've got to go run in there.
Hello? Where'd he go?
Sorry. She has to go to sleep with a soother, and so we put 6 of them in her crib. She likes to sometimes take all 6 and throw them away. So she was mad that there was nothing there. Now she's perfectly content. Ah, kids. Don't have kids. Well, do, but...
Wait, so is Tetra 5?
Pardon? Tetra?
Carbon tetrafluoride, would that be 5?
5 what? Carbon tetrafluoride is CF4.
CF4?
Yeah. So, next, after OF2, we're going to look at... I'm only going to do one of those two because they're fundamentally the same. Does anyone have a preference, oxygen or nitrogen?
What?
I'm going to do one of these two. Which?
Oxygen.
Oh, I know why you want oxygen.
What game was at my high school? Oxygen.
I know why you want to do oxygen. What happens if I... Well, because... Oh, this is interesting.
Please do oxygen.
Yeah, well, look right there.
Yeah, exactly.
Yeah, so I'm going to do nitrogen. And I'm going to update the... What? What are you talking about?
I can't see it on my screen yet.
Like, are you looking... Like, if you... Did you download the PDF? Or are you on your phone?
On my computer.
Oh. If you don't, like... I opened it online. You can zoom in. And, like, well, there's CF4. CF4, BBR3, O2.
CL3?
I think so, yeah. So let's do nitrogen. Into...
Let's do oxygen.
Yeah, well, I'm doing nitrogen. Deal with it. So 2 nitrogens times 7 is 14. If there's 2 elements, N, N. That's the only way you can put them. So we need to start with 2 electrons here. So let's go around. 1, 2. Add them, and I'm doing this for a particular reason.
You were not doing that for 6 hours? No,
Oh, I'm switching colors for a particular reason. Because if we do the whole thing and we add electrons, we have 2, 4, 6, 8, 10, 12. What? Oh, that's because I'm an idiot. Nitrogen is 5. 7 is chlorine and fluorine, so that's 10. So we only have 10 electrons to play with, and I've done 14. So when we get to that kind of situation, I need to take that pair and put it in there. And that pair is going to go away. What type of bond would there be now if this worked out? There's 2 pairs, so it's a double bond. So we've got too many electrons, so we get rid of. We take 1 blue pair, take 1 red pair. Now is... Sorry. Is this one happy? 2, 4, 6, 8. 2, 4, 6, 8. So everything is good. And we have nitrogen, nitrogen. There's 3 pairs, so we have 1, 2, a triple bond, and then we have that green pair of electrons, which I'm just going to rewrite as that color. Oxygen's the same idea, but it's 12.
This be good for oxygen. Can you see that?
Oh, just a sec. I see PCl3. Now I see a desk.
This is so hard. I can't put the camera.
Why can't that's Oh, because you're on your computer. I see what you mean. Yeah, yeah. So, so that's a diatomic molecule. Oxygen is going to be the same, but instead of that 6 and 12, so because it's 6, I had to have, or because I had 10, I had to have 3 pairs. Oxygen has 2 more electrons, so you might be able to give a little bit of a hint. We did C2H6 yesterday. Are we good so far?
Yeah.
Yep.
12. Okay. So C2H4 and C2H2 are both similar to the C2H6 that we did yesterday. 2 carbons times, no, it's 4, is 8. 4 hydrogens times 1 is 4. So that has, apparently I can't add at the moment. If we have 2 carbon atoms, we have 2 carbons side by side. It's got to be the case. So we have to have at least 1 pair in here. We've got 4 hydrogens, so symmetrically we're going to put, well, I'm going to do it like this. H, H. I'm going to put 2 on each carbon because that makes sense in terms of symmetry. How many electrons can hydrogen have?
2.
So, well, 2, that makes a bond. 2, that makes a bond. Sorry, I'm watching Kate bounce around and try to get comfortable. 2, that makes a bond. 2, that makes a bond. So the hydrogens are all happy. The carbons now each have how many?
So 6.
So let's, in total, you've got 2, 4, 6, 8, 10. So can I put, like, the kind of formal thing to do as well, add electrons to both. Well, that gives us 2, 4, 6, 8, 10, 12, 14, which doesn't make sense. So I'm going to get rid of those. Where can I put, oh, okay, in between the carbons. So if I do that, this carbon has 8. The carbon on the right has 8. Everything's happy in terms of a structural diagram. These carbons are, if I close that, I won't hear things. Hydrogen, 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 hydrogen. So would C2H2 be similar in idea to this one? The only difference is, what is she doing? C2H2.
So what are you trying to get down to 0?
Well, like you have to have 12. So when you add, like I tend to count, well, the blue ones, I would subtract 2, 4, 6, 8. So I know I have 4 electrons left, and I can put them in there. It's not really trying to get to 0. It's just an accounting thing.
So you can only have 32 valence electrons, and they have to like figure out how to get out everything you could.
Kind of, but you can only have however many are in the molecule. Like, so 2 carbons for C2H2 is 8 and 2. So C2H2 has 10. So carbon, carbon, we have to start with 1 pair here. Hydrogen, hydrogen. Well, we have to have a pair as a bond. So 2, 4, 6. So I've already used, like I'm counting what I've used. So I've used 6, I've got 4 left. This carbon has 4, this carbon has 4. I can't put 1, 2, 3, 4, 5, 6, 7, 8. I only have 4 left. So where are the other ones going to go? Where do the other 4 have to go to make everything happy?
Around between the carbons.
So 1, 2, 3, 4. So if I look, this is where I have to make a bunch of boxes. If I look at each carbon, well, that whole thing, this carbon has 8. This carbon now has 8. So go away, go away. Oh, I can't put it there because then I won't be able to see.
So what do you mean by BBR3?
Boron with 3 bromines.
Oh, I thought, okay. So,
And now Ben is talking to himself. So we got 3 more, and then I'll be done for today. So SO3. 1 sulfur is 6. 3 oxygens. 6 is 3 sixes are 18, so that's 24. Sulfur is going to be in the middle because it's the least electronegative. Oops. O, O, O.
does bromine only have 5 valence electrons?
No. Bromine has 3.
Wow.
Because it just does.
1s2, 2s2. You said.
Oh, I'm in the wrong file, so I don't have that. So for Matt, and bromine is right here, right? On your periodic table?
No, that's boron.
Oh, bromine is down here.
Bromine's like right there, yeah.
Bromine has 7. Boron has 3.
How's it 7? Because there's 1,
1,
2.
2,
That's why, like,
3, 4, 5, 6, 7.
oh, you didn't have to do the 1s2s.
No. All right. So sulfur trioxide is a little bit interesting because this is our first time where we have something after the second row. We can do everything the same, but after the second row, there's a couple of tricks that can happen. So I've used 6 electrons to stick those 2 together. So, well, let's fill oxygen up. So that one's got 8. So if I look at any one of the oxygens right now, like that oxygen right up here has 8. All of the oxygens, regardless of how you look at them, have 8. But 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We've got 24 electrons. What's wrong, with this? Can sulfur only have 6? No. So this one is kind of special. If I get rid of that pair of electrons there and put them right here, does that oxygen still have 8? 2, 4, 6, 8. Now does the sulfur have everything that it wants?
Yeah.
So that one's not really one for a test, but if it's after, like if it's in the third row, we have this kind of tricky situation happen. I'm just going to do that. So I have sulfur, oxygen, oxygen. This one has a double bond. That has 2 electrons. They don't, it looks kind of funny. Whoops, that was a bad line in there. That's going to drive me nuts, so I got to take it out. Oh dear, that erased a lot. So this is the Lewis structure for sulfur trioxide, which is something that's an industrial chemical and all of that. Now, I picked taking a pair of electrons from here and moving them in there. Could I have done a pair of electrons from here and moved that in instead? Or any of the other ones? So because you can kind of pick whichever one you want, I could just as easily have had a double bond on this side. Like, even though they look different, fundamentally, those are the exact same thing. I've got a sulfur with a double bond here and 2 single bonds. Double bond, 2 single bonds. So in chemistry, because this has kind of a nice triangular shape, that actually, technically, I can draw a third one where I can have a double bond here, or I can have a double bond there. And it's a little bit of an interesting case, but everything is valid. HNO. No, what just happened there? Okay. One hydrogen is 1. 1 nitrogen is 5. 1 oxygen is 6. So that's 12. Get out of here. Of those 3, which is the least electronegative? Well, technically hydrogen, but can hydrogen be in the middle? So we're going to put nitrogen in the middle, put a hydrogen here. Whoops. Just going to move it a little bit. And an oxygen there. So I know I need to put 2 electrons here and 2 electrons there because they have to be initially stuck together. So that's taken care of 4. So I've got 10 electrons left. So 1, 2. Thank you. Thank you. That's like the 3rd time I've done that today. I don't know. So 4. Everything has 8. Awesome. 2, 4, 6, 8, 10, 12, 14. Uh-oh. I think 2, 4, 6, 8, 10, 12, 14. I've only got 12. So this is a situation. Can I do that? Get rid of those. Now I've got 2, 4, 6, 8, 10. Where's that? Put 2 in here. H. That nitrogen is now happy with 8. I can put a double bond here. Interesting. I need to look that up. Not really, no. I'm trying to. What's the problem with this one, Matt?
Well,
You said this is whack. Are you talking about this, or are you still working on the assignment?
really assignment, like,
Well, you're supposed to be listening to me do this.
those ones are easy ones, man. Do we have to draw the molecular shape or state the molecular shape?
You will eventually, but I haven't showed you how to do it. And this one is one,
Like,
yeah, we'll talk about shapes tomorrow. And we may not have to, it might just be do the shape for a couple of them because some of them are a little bit tricky.
is the whole point of it to use the amount of like valence electrons that it gives you?
Yeah, it's making
No
sure.
matter how it looks.
Not really. So,
That feels good.
are you trying to show me something again?
Did
B
you see the boron one? The two?
well, it's BBR3. Go the other way. I see that everything looks good. Now you're just giving everybody else your answers. You're going the wrong way. Other way. Nope. Down.
Right there.
Yeah. So you've done all that. Yeah, your answer looks fine. Boron boron can only have 6 electrons. Borons and for now. Take more chemistry and what? C3H6. Last one. Oh gosh, she's still
Everything wants 8 except for hydrogen and helium.
hydrogen, helium, and boron technically wants 8, but if you actually drew what be the actual structure, what are you doing standing up again? See this? I don't know if you guys can see that. She's standing up. She's probably turfed another soother. All right, well, I'll do whatever this is, some sort of C3. 3 carbons times 4 is, I tried to write a 1 and a 2. 6 hydrogens times 1 is 6 is 18. So this one, I don't think there's anything like that on your assignment. No. This one's a little bit tricky because she's soothers are on the floor, I assume. Not really. I went in and put 2 back in, but sorry. So we're going to have some sort of arrangement like this, but if I put 2 hydrogens on every one, which is possible, this is where the more elements you have, the trickier this gets. So if I have like that, okay, so there's 2, 4. I know these are going to have 2. So if I bond everything together, 2, 4, 6, 8, 10, 12, 14, 16, I've got 2 electrons left. Well, if I put 2 here, everything is good except for that carbon. If I put 2 here, everything is good except for that carbon. So now we run into a couple of issues. So now this is where if I
move a hydrogen next to the carbon.
so that's one solution. If I take that hydrogen and move this over to here, so now the carbons and hydrogens are good. 2, 4, 6, 8, 2, 4, 6, 2, 4, 6, 8, 10, 12, 14, 16. Well, whoa, that's not at all what I wanted to do. So I can do that, but I'm still a little bit, I still have a bit of a problem. Right, there's 2, 4, 6, 8, 9, 10, 11, 12, 17, 18. So that doesn't really help per se. So this is where it's all about moving things around. So I'm actually going to take those and those away. So what happens if I put that hydrogen over here and stuck those other two electrons in here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 4, 4, or 4, 8, 8, and 8. Is that happy now? Everything looks good. I just moved the wrong hydrogen. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 12, 14, 16, 18. We have 18 valence electrons. Carbon has 8. Carbon has 8. Carbon has 8. So that works. H, C, H, a double bond, C, H. Is everything happy now? That is an acceptable Lewis structure for that. There is another slick one. I'm going to draw the 3 carbons at the start bent. Oh, I'm not going to do it in that color because we're just going to. There's actually no wrong way to do this one. There are 2 different shapes. So if I put so 2, 4, 6, 8, 10, 12, 14, 16. Could I put 2 electrons in between those 2?
Wait, does hydrogen have one valence electron or two?
Hydrogen has 1, wants 2. So if I put 2 in here, that connects these 2. And we get a ring of carbons because each carbon has 8 electrons around it. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. This one is called propene. This one is cyclopropane. Those are 2 things that you will need to know. Well, you'll learn in grade 12 chemistry. But when you have this kind of situation, you can have more. If I gave you C4H10, there's a number of different situations. The more you have, the more possible structures you can get. So all I really wanted to do today was go through a couple of those. And I'm going to have to put those into that notes file.
Question about the assignment.
Okay.
For bonding, like for you, like how like I have like the 24, but it won't fit because there's an empty spot under the boron. But then I tried to move like 2 of them beside them, but then there's still one open spot. And I was wondering if you like could put like 4 above the boron instead of like
You
on the side.
you can, but boron over here, boron generally, it's not super happy, but it's content. Boron, you can draw valid structures with 6 electrons because it's only got those 3 to start. So that one is one where boron on that question will only have the proper structure only has 6 electrons
Okay.
around it. And we'll, I think, talk
Wait, what?
boron. You can draw a
I
valid.
thought I did that one right, but I think I did it right.
Well, however I looked at it, it looked okay. What do I do in here? Well, we'll talk about that eventually, but I gotta go through and figure out what I have to post because I've deleted my file and feel like a total idiot. So boron will only have six electrons around it, and that's what yours looked like, Matt. So I'm not sure what that problem was. So that's all I wanted to do for today. Is there any other questions? I mean, we have a little bit of time before an assignment is due. And everybody's good?
I think so. Thank you.
Thank you. So we'll meet back here tomorrow and we'll talk a little bit about shapes and polarity tomorrow. But we'll see how far we can do. No problem. Have a good afternoon.
Do
Bye.